In 1610, a Venetian publisher released a pamphlet documenting what happened when a mathematician named Galileo Galilei took a glass tube, outfitted it with magnifying lenses, and pointed it at the night sky. For centuries, the established belief was that the moon was a smooth, immaculate sphere made of something resembling crystal. But Galileo published a radical observation. The lunar surface was actually rough, cratered, and carved with valleys, much like the Earth. This is a set of engravings published in his treatise. By focusing on the jagged boundary between light and dark, Galileo provided visual documentation of lunar craters and mountains. The scientific and religious establishments pushed back hard. Leading astronomers, including the prominent Jesuit mathematician Father Christopher Clavius, publicly declared that Galileo's sightings were complete fictions. Clavius's argument was highly logical for the time. He accused Galileo of using curved glass that inherently distorted reality. Clavius argued that the telescope functioned as a projector, casting pre-painted images or internal distortions directly into the viewer's eye. This created a deep problem for the birth of empirical science. How do you prove an objective truth about the universe when your primary observation tool is widely known by the public as an instrument of deception? To understand why society was so suspicious of optical glass, we have to look at how lenses and mirrors were actually used in the 17th century. They were the premier tools of natural magic, a blend of proto-science and high-end theatrical entertainment. This diagram shows the mechanics of a camera obscura. Figures like the polymath Giambattista della Porta would use darkened rooms with a small pinhole to project outside sunlight onto a blank wall inside. He staged elaborate hunting scenes or mock battles outside, casting the inverted images indoors to terrify and thrill his party guests. But if you place a specific convex lens or mirror at that pinhole, you intercept the light and flip the projection right side up. Suddenly, those ghostly shapes look perfectly real, standing upright in the room. Artists also exploited optics to hide secrets in plain sight. Take a look at this painting of Edward VI. It appears as a heavily distorted, unreadable shape, a technique called anamorphosis, until you view it from a drastic angle or through a specific curved mirror to correct the perspective. Public experience with lenses was defined by the theater and the parlor trick. This popular association made the glass a symbol of artful deceit rather than a reliable window into reality. Yet the foremost astronomers and the greatest stage illusionists of the era were purchasing their glass from the exact same artisanal workshops. This trade card from an optical shop shows telescopes, microscopes, and various lenses sold side by side. Functionally, these instruments were practically identical. They just utilized different sequences of convex and concave glass placed inside different tubes. This diagram illustrates how scientists like Johannes Kepler used the exact same camera obscura setup that Della Porta used to fake floating men. Kepler simply aimed the chamber at the sky to safely project, trace, and study the movement of sunspots. The hardware of theatrical magic and scientific astronomy shared a common technical blueprint. The glass doing the projecting was identical to the glass doing the discovering. Which brings us back to Galileo's problem. With the physical technology inherently suspect, he needed a completely different method to prove his lunar observations weren't just smudges or tricks painted onto his lenses. He found his solution in his own background. Before he was a mathematician, Galileo received formal, rigorous training in artistic draftsmanship and perspective at the Florentine Academy of Art. He applied the artistic concept of chiaroscuro, the study of light and cast shadow to render three-dimensional volume, directly to the strange patches he saw through his telescope. These are his original pen and ink wash drawings. Over a sequence of nights, he meticulously mapped exactly how sunlight caught the raised mountain peaks first, before slowly creeping down to illuminate the valleys below. Look closely at the terminator line, the boundary where the light meets the dark. By tracking how these shadows changed shape over time, Galileo proved a physical reality. The shadows behaved exactly like light hitting a massive three-dimensional terrain. A flat painted illusion hidden inside a glass lens could never replicate that dynamic shift. It was the subjective, highly trained eye of the artist that ultimately authenticated the objective truth of the scientific instrument. Galileo's artistic proof defeated his critics. Within years, the telescope was rapidly adopted across Europe as a premier instrument of discovery. The ornate, gold-tooled leather casing of his own telescope shows how quickly it became a coveted object among the elite. The success of the telescope forced a re-evaluation of how knowledge was acquired. Where scholars had once relied primarily on the authority of classical texts, they now had to account for the physical evidence provided by the eye and the lens. This era birthed the epistemic image. Drawings and engravings were no longer just pretty illustrations accompanying text. They functioned as the core, unquestionable evidence of scientific knowledge itself. This shift is captured in the frontispiece to a text by Emanuele Tezzaro. The telescope evolved into a literary shorthand for clarity and truth, appearing in the works of poets like Milton and Donne as a symbol of expanded human sight. Science and art shared a common ancestry in the study of light and perspective. To reach an objective understanding of the stars, observers first had to master the artistic grammar of shadow.